Do you believe in miracles? Well, if there is a miracle, and I believe they are miracles as someone who's a Christian, it would have to be the process of childbirth and the process of embryological growth and development. Welcome to the latest episode of Testable Faith. My name is Fuzz Rana. I work for an organization called Reasons to Believe, which sponsors this particular program. And today we're going to talk about what does embryology tell us about human life. And I'm joined in studio today by Dr. Christina Cirucci, who is an expert in this area. She's a medical doctor whose specialization is obstetrics and gynecology. Chris, thanks for being here with us today.
Good morning, Fuzz. Thanks so much for having me. It's great to be here.
Yeah. So we'll just start off the conversation with maybe a basic question. What exactly is embryology?
Sure. Well, there actually is not a total consensus, but in general, and I will speak this way, we speak of embryology as the first 8 weeks from conception. Now, with that said, we realize that human development is a process. So it's not that at a certain point in time, embryo to fetus, it's a whole process of development of this beautiful human being that God's created.
Right. So embryology is the study of embryonic development.
Exactly.
And for a human, it's roughly the first 8 weeks, and that's considered an embryo. Then after that, it's considered a fetus. Okay.
Right.
Okay, great. So when do you believe that life begins? This is, of course, a huge controversy, not only in science and medicine, but also in our culture at large. So when do you believe life begins then during this process of embryology?
It's a great question. I believe that life begins at fertilization, at conception. Now, certainly as a Christian, that informs that belief. But really, that belief is also rooted in science. From science, we can know that. So, as you know, each human being has 23 pairs of chromosomes, and at fertilization, this human being gains his or her own set of 23 chromosomes, half from the mother, half from the father, and is a unique genetic human being. The human sex, eye color, hair color, these are already determined right at fertilization.
All right. So and I would agree with you too, and for very similar reasons. Part of it is my faith informs me of that, but also scientifically, I think there is actually a robust case that can be made that human life actually begins at that point. So then, I think that the process of embryological development is just mind-boggling in terms of just the elegance and the sophistication and the forethought and the pre-planning. Just give us a little bit of a description of what happens during the course of embryological development after fertilization takes place.
Yeah, I agree with you. It is pretty amazing, and it's quite complicated. So let's talk about the first week.
And I think it's fair to say we don't fully understand the process either, right?
That's absolutely fair to say. I know I don't understand the process fully. I don't think anyone does. But so let's just talk about that first week. So fertilization occurs in the ampulla of the tube, which is kind of in the middle part of the fallopian tube. So we have the egg and the sperm meet there. Now, every one of our body cells, except the germ cells are the egg and the sperm, have 23 pairs of chromosomes. So the egg and the sperm cells have 23 single chromosomes. So what happens is the egg, or also called the oocyte, has a surrounding layer called the zona pellucida. And one sperm out of all those millions will penetrate the zona pellucida and enter into the oocyte. But what's amazing is the sperm attaches, and then there is a reaction called the acrosome reaction, where the sperm will digest the zona pellucida and enter the egg. And then there are things that happen that prevent another sperm from entering. So the zona pellucida cells will change so that they can't allow another sperm. So then the DNA of the 23 single DNA of the sperm and of the egg, these intermingle and divide, and you have an organism with 23 pairs of chromosomes. And that one-celled organism called a zygote. So that's all at fertilization. And then what happens is the cell, through mitotic division, becomes 2 cells, and then 4 cells, and then 8 cells, and then 16 cells. And by about day 3, it's 32 cells called a morula. Now, a morula is that term is from a Latin term for mulberry.
Yeah.
Which I think is interesting because when you see a picture, it kind of looks like a mulberry.
Now, at this particular point, there's not really much cell growth, right? It's mostly cell division, right? So the size of the morula is about the size of the original egg cell. Is that right?
Correct. The cells are replicating, but the actual organism is staying the same size. Yes. Yeah. Now the morula, think of a solid ball, like a golf ball. Now there's actually, interestingly, a difference in polarity in those cells. So the cells on the outside will have a different polarity than the cells on the inside. And because of the changes, the difference in the sodium-potassium pump, that allows fluid to enter into the inside. And if you think of fluid entering in the inside, and then it will push some of the cells, the inner cells, to one side of that sphere. And those cells are called the inner cell mass,
right.
The embryoblast. That is what will become the beginnings of the embryo. And then that outer core, or the outer cortex, I'm going to call it, is the trophoblast, which becomes a placenta. So this is all. We're still in the first week. Yeah. We haven't even implanted yet in the uterus. And then around day 7, implantation occurs. So the trophoblast, which is that outer core, differentiates into 2 more layers, the syncytial trophoblast and the cytotrophoblast. And the syncytial trophoblast is what will invade the endometrium and implant. And that's around day 7. And so there you have the beginnings of the circulation, because, for the baby to get nutrients, there's blood flow between the mother and the baby that happens through the placenta, and this is already starting at that point. So that's pretty amazing. I mean, this is all in the first week.
Yeah. So then what would be some key milestones that in the process of embryological development?
Right.
And this, it's remarkable. And you probably just gave an overview of what's going on.
Yes.
I mean, when you start thinking about, just the biochemical processes that are happening in the cells in response to what's going on, it's mind-boggling.
Right. So week 2, the embryoblast, or that inner cell mass, then differentiates into 2 layers, the epiblast and the hypoblast. And then week 3, we have a process called gastrulation, which is pretty amazing because, in our body we have kind of 3 types of cells, as you know, the ectoderm, the endoderm, and the mesoderm. So the ectoderm is what becomes our skin and certain nervous system, and the endoderm is what develops into the liver and lungs and intestines and other organs, and the mesoderm is what becomes muscles, bones, heart, blood vessels, blood cells. So on week 3, the process of gastrulation is those cells differentiating into these 3 cell types. So what happens, you have this inner cell mass, or the embryoblast, and these cells will migrate and then invaginate and form these 3 layers. And there's all kinds of, you're a biochemist, so this is really more your area than mine, but these cells are connected, are kind of held together by a molecule called E-cadherin. And again, in order for them to migrate and move and form these 3 layers, there's another substance called fibroblast growth factor 8 that is released to allow these, to counteract the E-cadherin. So it's a pretty just amazing process. So here we are at week 3. We have these 3 different kind of cell layers that are going to, we're starting to developing into the organs of the body. And then at day 22, the heart starts as a tube, and by day 22, that heart tube is beating. Now, as an obstetrician, I see that heartbeat often on ultrasound, and that's 4 weeks after fertilization, we can see that. And you can really see, and the other thing at week 3 that happens is you get the polarity, meaning which end is the head and which is the feet, and this is all an amazing process. I mean, it's really almost like a symphony, that God has orchestrated.
Well, because as you're describing this process, particularly once you hit the stage of gastrulation, the cells are beginning to, replicate.
Right.
They're growing, they're migrating relative to one another.
Right.
They're undergoing specialization, which involves turning genes on and off at the precise time. They're beginning to secrete chemicals that are creating gradients that are directing some of this activity. Michael Levin thinks there's even electrical gradients that are actually playing a role in regulating the development. As you mentioned, cell polarity, can differ. And then, of course, you're having all these intercellular interactions that are forming, reforming. As you continue the developmental process, there's even cell death that's taking place to help sculpt things. You mentioned it being like an orchestra. An analogy that I heard, I wish I came up with this, but I didn't. It was actually, I heard Paul Nelson say this, but it's like a marching band going onto a field at a halftime of a football game, spelling out, I'm from my graduate degree was from Ohio University, spelling out Ohio, right? You have somebody has designed the choreography ahead of time, but each individual band member is doing something very different, but yet highly specific. And if they don't do it precisely the way they're instructed, it's not going to turn out right. Mm-hmm. They're not going to spell Ohio. It's going to look horrible. And so each individual is essentially working in conjunction with each other individual as they're carrying out their specific tasks. And to me, that's a great, I think, metaphor for what's going on. But the key point is that there has to be someone that's designed this ahead of time. There's forethought as to what's happening. I mean, what's your reaction to that analogy from Paul Nelson?
I agree. I love that analogy because when you are sitting in the football stands and watching the marching band spelling things out, and it's also choreographed, and clearly if one person totally messes up and walks off the field, it's going to look crazy. But there's clearly a design behind that. And yes, when you study embryology and just these, again, like you said, I'm just giving a very brief overview in this short time we have, but there's so many more details that we don't even understand. But to me, that points to a designer.
Yeah. And so when you see passages in Scripture like, God's knitting us together in our mother's womb, or, we're fearfully and wonderfully made, when you really start getting a glimpse as to what's happening from an embryological developmental standpoint, it's, those passages just take on a richness, I think.
Absolutely. Yes, I love that verse because I think that does speak to what we just talked about with embryology.
Yeah. So anything else that impresses you about embryological development?
Oh, it's just the whole process. And as a obstetrician who takes care of these women who are pregnant and their babies, I'll tell you what, you never get tired of it. Well, it's at 6 weeks, there's 2 different dating mechanisms, but 6 weeks of gestation, which is really just 4 weeks after fertilization, we see that heartbeat. And I know there's a lot of talk about that lately in the media, but it's certainly powerful. I never get tired of it.
Yeah. Oh, thank you, Chris.
Yeah.
That's awesome. Well, I hope you enjoyed this episode of Testable Faith. I would invite you to go to our website, reasons.org, and search for Chris Cirucci's name, and you can get access to a lot of resources that she's produced for us here at Reasons to Believe. And so until next time, remember, the more we know about science, the more we have reasons to believe.